Sorry, so before that, my name is Fahim. I work with Webit Solutions as consultant and trainer. So we do both actual development as well as training and so on. Okay. So before we discuss what's new in 2016, I'll first of all quickly review the features that were added to SQL Server 2012 and 2014. I've also delivered webinar on these versions as well. So if you guys want to look up for these features, you can go to this website. So if you follow the website, you'll see past webinar section, and there you should be able to see SQL Server 2012 and 2014 best webinars. So basically, in today's agenda will mostly be about SQL Server 2016. So we will cover always encrypted feature, JSON support in SQL Server 2016, dynamic data mask, multiple temp database files, query store, row-level security, stretch database, temporal tables, polybase, and R processing or R language. So there are quite a few features that have been added to SQL Server 2016, and I've tried to pick up just the most important features that are available in 2016 that I'll try to cover in this webinar. So before that, let's quickly recap what was added to SQL Server 2012 and 2014. So there were definitely a lot of features. So obviously, I'll not go through all of them, because if I do, then the entire webinar will be based on just these topics. I'll not be able to cover any 2016 based topic at all. So for that, I'll definitely recommend you guys to go to this website, look up for these SQL Server 2012 and 2014 based webinars that I've presented in the past. I'll just quickly review some of the very important features that were added to SQL Server 2012 and 2014. So for example, we had AlwaysOn, which allows us to create up to 8 replicas of a database. So this way, if the primary database has gone down, then some secondary database will become the active database. So this way, your clients will not get disconnected. They will continue to access the database and so on. Likewise, in-memory OLTP, it was another very useful feature added to SQL Server 2014. In-memory OLTP allows us to store data in the memory, and it allows us to access the database in a very, very fast manner. So it's up to 30 times faster than the regular database. There are definitely lots of additional features as well that were added to 2012 and 2014. Okay, so let's start off with one of the first features that has been added to SQL Server 2016, that is always encrypted. Always encrypted, as the name suggests, it's about security. In the past, we had a feature called transparent data encryption, short form is TDE, which basically allowed us to encrypt the entire database. If you encrypt the entire database, the benefit is that no one can try to decrypt, or no one can look at the actual data that's stored on the hard drive. So say that maybe you're using cloud-based environment. You're storing your database in some cloud-based server. So in that case, you will definitely not want the vendor who's hosting the databases on your behalf to look at your data. Because usually if you have access to your MDF files, LDF files, and so on, you can easily attach those databases to any instance, and you can look at the data. So in the past, we had a feature called TDE, which allowed us to encrypt the entire database. So this way, only the person who has the same digital certificate that was used to encrypt the database will be able to look at that data. So basically, if you want to encrypt the entire database, basically on the storage, then for that, in the past, we used to use TDE. It's definitely a good feature, but one of its drawbacks is that it's very heavyweight, in a sense that you get to encrypt the entire database. So do you really want to do that? If yes, well and good, you can use this feature. Otherwise, you can say that, no, I want to keep my database as lightweight as possible by not adding too many extra features to it. I just want to secure maybe 1 or 2 or 3 columns. So in that case, you can use always encrypted feature that's available in SQL Server 2016. It allows you to pick and choose the columns that you want to encrypt. So you get to encrypt the data at column level basically. And again, once we have encrypted the data, no one can look at the actual data that's stored on the hard drive unless and until they have the exact same digital certificate that was used to encrypt the data. So it's mostly useful in scenarios where you're using someone else's storage for storing your data. If you have on-premises scenario, it might not be very useful, because in that case, if you are the DBA, if you are located on the same server, then it's okay because you own the servers, you work for the organization, so it's okay for you to look at the data. Otherwise, even in that scenario, even in case of on-premises, if your DBAs, they do not have access to the same digital certificate, then even in that case, the DBAs will not be able to look at the same data. Your client application, as long as it has the same digital certificate, it will be able to connect to your database, and without writing any special piece of code, it will be able to retrieve the data in an encrypted format. So basically, it's seamless encryption as long as the digital certificate is known by your client application. Let me give you a quick demo of Always Encrypted feature that's in SQL Server 2016. So here I'm going to use my virtual environment. I already have SQL Server 2016 installed here. Then to save some time, I'm also going to utilize some scripts as well. And actually, for this purpose, I can utilize just the GUI-based feature, or let me write a quick script here. Okay, so let's quickly create a database here. So create database test DB. Then let's quickly create a table as well. Let's add a couple of columns to it. Let's say I'm just going to add a bunch of players. Let's say hockey players. So the first column, we don't really care for it, player name, or let's actually call it user ID. Username and password, I'm going to secure or encrypt the password column basically. Okay, let's add a bunch of records as well, or at least one record for now. So insert into secure test values. So let's say we have username Bob and the password is whatever the password is. We don't really care for it. Okay, so basically for now we have a simple database and a table with a record. Let's query it as well. So let's start from secure test. So we can see that currently it's not encrypted. So here I'm going to encrypt it, then I'll show you how it's physically stored on the hard drive. So for that, you can choose to write some code, or you can also choose to use GUI-based features as well. So GUI-wise, if I go to the table here, you will notice that I'm supposed to use this secure test database. Okay, so if I go to this database here, test DB. So here we have a table. So you can basically right-click the table, and you can encrypt columns. You can encrypt multiple columns like this, or you can also choose to drill down to column section, right-click the column that you want to encrypt, then encrypt column. It will show you this wizard that's available in 2016. Click next. So basically, I have right-clicked just a single column, so it's listed here. I can encrypt this password column. Then I can choose some encryption type here. So encryption type-wise, we have a bunch of algorithms plus various techniques. So I'm not going to go through all the details in this particular very short webinar. I'm just going to use randomized for now. And I need to create encryption key that will be used for encrypting the data of this particular column. So it's going to automatically create a key for us. I'll show you where exactly it's stored in just a bit. Then I can click next. Then you can choose to save the key along with the master key. Master key is basically the base key that will be used for generating the digital certificate. And once the digital certificate has been generated, after that you can create bunch of other keys based on the same certificate that will be used for encrypting multiple columns. So master key needs to be there, and I'm creating the certificate for it as well. Then you can choose to run it right away so that it encrypts the data for this column, or you can choose to save a PowerShell script and you can run it later on if you want. So now I'm going to run it right away. Finish. It will generate the master key plus the digital certificate, and it will encrypt the data for this particular column as well, the password column basically. Then I'll show you where exactly the key is stored in just a bit. Okay, so once it's done, we can close this one. Then before I show you the location of the key, let me query this table right away. So this time, since we have secured it, if I try to execute this particular query, you will notice that the password is no longer user readable. So we cannot read this password. It's encrypted basically. As long as the application developers, like let's say Java developers or .NET developers, they follow certain guidelines, like for example when they are creating the connection string, if they pass the information regarding the digital certificate and they install the certificate on their side on the machine where application is located, then the same SQL queries will be able to connect to this particular database and retrieve the data in unencrypted format. So basically, you don't need to write any special piece of code. The only things special that needs to be done on the client side is you need to install the certificate, and you also need to pass the name in the connection string. So that's all you need to do. Other than that, the data is saved in secured manner on the hard drive. So say you have created the database in some cloud environment or on some machine that's run by some vendor, it's hosted by some vendor. So in that case, you can now feel secure. You can feel safe that no one can look at your data. No one can just simply take the MDF file, LDF file that's on the hard drive and try to look at the data that you have in the database. Keys-wise, when you expand your security folder here, you will see always encrypted keys. That's a new folder that's available in SQL Server 2016. Here you will get to see your master key, plus you will get to see your encryption key that has been used for encrypting the data. And you still need the certificate. So certificate, you must have seen in the past that it uses public key, private key concept. So not everything is available in this key. It's not really a symmetric key. You cannot use the exact same key to decrypt the data. You need to use its corresponding private key or public key and so on. So basically, that's a quick overview of Always Encrypted. It lets you encrypt data at column level. It's much more lightweight compared to transparent data encryption that was added to previous versions of SQL Server. Okay, then second feature in SQL Server 2016 is JSON support. So as developers, we can retrieve relational data and present it in JSON format, or vice versa. We can save JSON data in some table and then we can manipulate it. So as developers, you must have seen that these days we try to use web services a lot. We try to use some data interchange format. In the past, we heavily used to prefer XML, whereas these days we have started using JSON quite a lot because it has much smaller footprint. In the past, we did have support for XML, but now we also have support for JSON. So before I show you JSON in detail, let me quickly show you XML-based support as well. So here I'm going to use a simple sample database. Okay, so if I query this table, you will notice that there's nothing special here at all. It's a regular relational table. But if you want to format it as XML, then you can use for XML, let's say auto formatting. So here we have taken the exact same table and we are presenting it in XML format now. So we have a bunch of tags, bunch of nodes here. So we have HR.employees, we have all the columns as attributes here and so on. So this is mostly useful if you want to utilize web services, etc. and so on. You want to use XML as a data interchange format. So now you can also choose to use JSON as well. So in 2016 allows you to present the same data in JSON format. So for that, we can use JSON auto for now. So here, if I open this one, you will notice that it's in JSON format. So JSON, as developers, you must have seen that it's a JavaScript object notation, which is heavily utilized by REST services these days. It's a data interchange format basically. So we can see that we have an array. It has this object number 1, which has a column employee ID. 1 is the value, last name, column is there, Davis is the value, first name is there, and so on. So basically, we have an array of records, array of objects basically. So this is JSON representation of that relational table. You can also choose to use some more options here. So for example, if you do not want to use just a nameless array, so currently it's a nameless array. We can see the square bracket here. It's an array without any name. So if you want to assign it some name, then for that you can use a path, and then you can specify some value here. Like for example, we can say employees should be the sort of container or object name. So it should not be a nameless array. It should be an object which should be composed of the array basically. So I'm going to name the root element employees. So if I execute this one, you will notice that this time around we have array, but before that we have employees as the object. So it's now an object which is composed of an array basically. So there are lots of other formatting options as well, but in short, JSON support is available in SQL Server 2016. So here I showed you how you can utilize some existing relational table and format it as JSON data. What if you have the other way, the other scenario? For example, you have data stored in JSON format, and then you want to convert it to relational table. So previously I converted table to JSON, and I'm going to show you how to convert JSON to table format. So if you want to save your JSON data in some table column, then you will want to use nvarchar as the data type. So if you want to save this data in some table as a column, you have to save it as an nvarchar sort of column. Let me show you a demo. Okay, so say we have some column in some table called employees. Currently, I'm not really saving this data in some table. I'm just creating a simple variable for now. So we have a variable called employees. It's of type nvarchar. This is important. So if you want to save JSON data, you have to use nvarchar as a data type. Then I'm storing this data. Initially, I'm storing just a couple of objects. It's not an array. We just have a couple of standalone objects here. This is object number 1. It has 2 columns. Then we have object number 2. Not exactly columns. These are sort of attributes for now. So if you have this sort of string-based data, or to be more precise, nvarchar, Unicode-based data stored in some column, then you can use this OpenJSON, which is sort of a function basically, or otherwise it's sort of a predicate basically. So select star from OpenJSON, then you can pass it the JSON-based variable or the column name. It will basically show you the JSON in tabular format. And by default, it adds this third column, which basically tells us what's the data type of that column basically. So it's telling us that employee ID is the column name, its value is 1. Employee name is the column name, Bob is the value. Numeric based data, that's of type 2, and string based data is of type 1. Likewise, Boolean, it has its own number. Date and time, it has its own number, and so on. So in most cases, you'll want to skip this type column. You'll just want to focus on the first 2 columns: column name, value, and so on. Plus, you can also check, or before that, let's just go for this one. So this time around, I'm going to use a slightly more complex object. So this time around, I have an object called employees, and I have an array assigned to it. Previously, I had a couple of standalone objects, whereas now I have an array assigned to this employees. So if you have slightly more complex object, then in that case, Your OpenJSON will have to be slightly more advanced, as you have to use some more parameters here. So this time around, I'm going to say that I want to query this employees variable, and to be more precise, I want to query this particular object, which is an array basically. So for that, we get to use dollar dot whatever object name you have specified here. So dollar dot employees. And likewise, if you want to assign aliases to the columns, then for that you can use with class here. You can say that the first column, it should have the alias employee ID. For now, I haven't really changed the name as such. I'm using the exact same name that I already have here. But potentially you can change the name if you want. There's one-to-one mapping here. You can change the name. You can also specify the data type as well if you want. So basically I have a couple of columns, employee ID, employee name, and I'm assigning alias to the table as well. So that's employees array. So if I execute this entire piece of code, you will notice that we have formatted the JSON data. Now it's much more user-friendly. We can see the column name here, employee ID, employee name is the second column, and we can see the values as well. So in a real-world sort of scenario, you'll want to use this sort of syntax when you want to convert JSON data to relational table. Likewise, there are more utility functions available as well for validating whether some string is a valid JSON-based string or not. So for that, you can use isJSON. It will let you know whether it's a malformed JSON string or it's a valid JSON string. Likewise, you can also retrieve some rows column as well. So rather than retrieving the entire table, you can say I want to retrieve just the row number once, column number one value, and so on. So here I'm saying that from this employees array, I want to retrieve first row's employee name. So if I execute this piece of code, you'll notice that it will retrieve Bob here. So we are able to retrieve certain rows, certain columns value. So basically, there's excellent JSON support that's built into SQL Server 2016, whereas in the past we just had support for XML. Another useful feature is called dynamic data mask. Dynamic data mask can be useful for sort of securing your data at the user level. So rather than displaying the actual data, you can say you want to mask the data. So just like we usually have masking for phone number, etc., and so on, you must have seen in various applications. So likewise, we have built-in support directly in SQL Server, which is not really for data entry purpose. It's more so for the display purpose. So how you want to display the data? So for example, if you have, let's say, credit card number to display, in most cases, you usually say you'll want to mask the first few digits. You'll just display the last 4 digits and so on. Likewise, if you want to mask email address, you can choose to do that as well and so on. So basically, masking allows us to return data that's not exactly encrypted, but it's sort of masked. So masking wise, just like for credit card numbers, usually we have this sort of mask and so on. By default, only the DBAs or the database owners will be able to see all the data in unmasked manner. If you want other users to be able to see data in unmasked manner, then we have to grant a permission called unmask. So unmask is a permission that's available in 2016, and you need to grant it so that users can see unmasked data. Otherwise, by default, non-DBAs and non-database owners will only be able to see the masked data. So let me show you a quick demo of this one. So basically, it's sort of a security-based feature that masks the data. So this way, you'll have to do less work as application developers in .NET and Java, etc. You'll be able to do most of this stuff directly at the database level. So here I'm going to quickly create a simple table called user2. I'm going to mask postal code, email address, and credit card number. So here we have masked with, and we get to use these out-of-the-box functions. We have a default function, we have email function, and partial function. Let me show you how exactly these look like. Before that, I'm going to add some sample data as well. So basically, in the table, I have this data. I have postal code, email address, credit card number, and it is unmasked to me because I'm the database owner. and the DBA, I can see everything in an unmasked manner. But if I try to create some other user account and I grant just the select permission without granting the unmask permission, if I try to execute or query this particular table as Bob, notice that it's utilizing the masking functions now. So email address is masked. So when you use email function, which is a built-in function, it's available out of the box. When you pass it some email address, it will always return just the first letter or digit or whatever it is. After that, it will always use X instead of digits and alphabets and so on. It will utilize the @ symbol. Then again, for domain name, it doesn't have anything. Then it does have .com here in the end. That's a default masking formula that's used by this email function. Likewise, we can use default masking function, which will basically replace all digits with zeros and alphabets or letters with X's. So default replaces digits with numbers, etc., and so on. Then credit card number, for that I'm using another built-in function called partial. So partial takes up to 3 parameters. The first one is the starting position, then what mask or prefix we want to return, and how many digits we want to return from the end, basically. So here I'm using partial built-in function. So notice that it's taking this particular credit card number, it's masking it. So it's returning just the last 4 digits, and it's replacing the first few digits with X's here. So in the past, we had to do it at either store procedure level or we had to do it at application level, whereas now we can do it directly at the column level, basically. So we get to specify these functions. So that's dynamic data mask. Then another feature in SQL Server 2016 is multiple temp DB database files, which is not really a new feature as per se. It was available in the older version as well. So basically, in the older versions, plus even in the new version, the best practice is that we should always have multiple temp DB database files. So as DBAs, you must have seen that you can create multiple database files. So for example, if I go to any random database for now, I can go to its properties, I can go to files, and we can add multiple files to it. So additional files, they will have .ndf extensions. So you can add multiple files. So as DBAs, we all know that there are various reasons, like you want to scan multiple hard drives, or you want to make sure that certain data is in one file, other data is in some other file. So you can use it for data partitioning, etc., as well, and so on. In case of TempDB, we usually recommend creating multiple files so that you can improve the performance, especially when you have multi-core machine, which we have these days. So if you have multiple TempDB files, it will basically improve the performance, because each core will be able to utilize a separate file. It will be able to write to it in faster manner and so on. In the past, we had to do it after installing SQL Server. So we have to install SQL Server, then we used to open Management Studio, then we used to go to TempDB, and we used to add these files. Whereas now in SQL Server 2016, it is possible to do it at the time of installation of SQL Server instance. So when you're trying to install SQL Server, in one of the screens where it usually asks us to specify the data directories and file stream option, that's where we have this TempDB option, and we can specify additional files that should be part of that TempDB database. So basically, it's a best practice, so why not do it right away at the time of installation rather than waiting till the end. Why do it after the installation when you can do it at the time of installation? So it's a small feature, but it's fairly useful. Then another feature in SQL Server 2016 is called Query Store. Query Store can be useful both to the developers as well as to the DBAs. It actually depends on who is responsible for query optimization or performance optimization, query fine-tuning, etc., performance time fine-tuning. So it all depends on who is responsible for it. So in the past, for the sake of improving performance, we usually used to look at the query execution plans, the estimated execution plan, the actual execution plans, and so on. And we also used to rely on SQL Profiler, SQL Trace, and data management views as well. In the past, for optimizing the queries, usually only the cached queries, the cached plans were available to us, unless and until you use SQL Profiler or SQL Trace and record everything. So if you record everything, then sure, you will have data that spans over multiple days or weeks, etc., and so on. So you can record all the queries if you want. But we all know that SQL Profiler, it does have some extra overhead because you have to leave it running. It's a GUI-based tool, so it does cost extra overhead. SQL Trace, although it's lightweight, but there's lots of extra configuration that you have to do. And usually the code that you have to write for enabling SQL Trace is fairly long. Now in 2016, we have a relatively easier way, which is called Query Store, which basically stores all the execution plans. So it's a very easy to use tool that lets us store all the execution plans in a very easy way, basically. So it's an alternative to using SQL Profiler or SQL Trace or even DMVs. DMVs, its drawback is that it usually lets us access only the cached plans, not the historical sort of queries, etc. So let's see how we can utilize Query Store. So Query Store wise, you have to first of all enable it at database level. So for example, if I go to this database, or let me quickly create another table here. So I'm going to utilize this test DB, or let me actually see if I can utilize one of the existing ones. Sure, I can use secure test table. So basically, first of all, you have to enable Query Store, which basically means that you want to save all the historical executions of some query and so on, or queries basically. So for that, you go to the database, at database properties level, you can go to Query Store and enable it. So by default, it's not enabled at database level. And in order to enable it, you have to make sure you switch your database compatibility mode to the latest version. So in fact, most of the features that I've been discussing so far, you have to make sure that you switch your database compatibility level to the latest one in order to avail these features. So SQL Server 2016, which is 13.0 basically, you have to enable, make sure that this is set as the compatibility level. Then you can go to your Query Store, you can activate it, then OK it out. You can also choose to generate script for it if you want. OK it out. So that's a script that we use for enabling the Query Store, which will basically allow us to save the historical query executions and so on. Then I'm going to execute a bunch of queries here. So from OK, let me execute it a few times here. Oh, I have to switch to the regular DBA. OK, previously I had my context changed to Bob user, which I don't want to use anymore. OK, so once I've activated Query Store, here I can choose to write some code, or we can also choose to look at the Query Store graphically as well. Let me show you a bit of code here that we can use for looking at the Query Store data. So basically, if you want to look at the query execution plan, the text version of that plan, basically, for that you can choose to write this code. It will basically show us the queries that we have been executing. Some of them are system queries. You can also see our custom one as well. So let's start from secure test. You can go through these columns. You will get to see some useful columns. For example, you can look at the compilation time, etc., the date when the query got compiled, the number of executions and so on, the resources that got utilized by the query, etc. You can look at this text-based data, or you can also look at the graphical sort of data as well. For that, you'll want to refresh the database, and here you will see this query store folder. When you expand it, you will get to see some sample reports here. So here, let me look at the resources consumed by various queries and so on. One small note here, you'll definitely want to enable this feature, then wait for a few hours so that it can gather the data. Currently, it doesn't have too much data here, so it cannot really show very useful charts for now. Otherwise, for some of them, you can still see some data, but it might not show you the data for your custom queries right away, since we haven't really executed too many queries for now. But over a period of day or hours or days, once it has captured sufficient information regarding your custom queries, it will show you the historical executions, like how many times you have executed it, how long it took to execute the query. You'll be able to see the historical information of your execution plans and so on. So basically, it is execution plans, but rather than showing you just for the cached queries, it shows you all the historical executions as well. And it's much simpler compared to utilizing SQL Profiler or SQL Trace and so on. Then another feature in 2016 is row-level security. Previously, we discussed column-level security, which allows us to encrypt data at the column level. In SQL Server 2016, you can encrypt data at row level as well. So this way, you can say, let's say we are storing data for each city. So we have cities like, let's say, Toronto, Calgary, Edmonton, etc., and so on. And you can say that manager should be able to see all cities information. Bob should be able to see just Calgary's data. Alice should be able to see Toronto's data. So if you want to restrict the number of rows that are returned based on the user, then for that we can utilize this row-level security concept. For that, we get to create a security predicate or a function basically that allows us to specify what user should be able to see what data. Let me show you a demo of this one so it makes more sense. Oh, so I think I didn't save the query for this one. So it's a bit time consuming. I'll try to upload it later on as part of the webinar. But in short, what you get to do is you get to create a table. One of the columns in the table should contain username. So you create a table and you get to store your regular data, and one of the columns should store username. That should be able to see the data. Then after that, we get to create a security profile or a sort of a security predicate or a function basically. The function, you have to write the function yourself, and you get to specify that if username is this or this or this, in reality we get to use in predicate. So we say that if the user is in this list, then return these rows. So basically we get to create a function that specifies what column will be used for storing the username, and then based on that column we return the rows that should be displayed to the user. So row level security, there are a bunch of extra keywords, extra functions, extra policies that you have to create basically that allows us to encrypt data simply by specifying so based on certain columns value, you say that if username is found in this column, then return the row, otherwise don't return the row. So row level security is available in 2016. Then stretch database is another feature in 2016 which allows us to span our database onto the cloud environment. So definitely in most cases we try to keep the database in on-premises sort of servers or storage, but if you want to utilize cloud, then in that case you can span your database onto the cloud as well. So cloud-wise, officially Microsoft recommends using Windows Azure. So that's the official cloud provided by Microsoft. So you can create a file or multiple files in the cloud environment, and you can connect them to your database that's stored in on-premises sort of environment. So just like we usually get to create multiple .ndf files, secondary data files. So likewise, you can create the secondary data files that can be in the cloud environment. And what's the benefit of creating the data files in cloud environment? Why span the data onto the cloud environment as well? There are lots of benefits. One benefit is that you can choose to use it for archiving your data. So you can keep your most frequently accessed data in on-premises storage, and you can archive the non-frequently accessed data in the cloud environment. And the beauty of stretch database is that when you later on write some application, you write some T-SQL code for querying the data, if data is available in on-premises storage, it will retrieve that. And if it's available in the cloud environment, it will still retrieve that. So database engine is responsible for knowing from where to retrieve the data. So in short, you do not miss any data at all. When you write the queries, you run the application, you still get to see all the data, whether it's in on-premises environment or in the cloud environment. So stretch database, in short, lets you utilize your on-premises storage as well as the cloud storage. So think of it as data archival sort of solution. So mostly it's used for archiving the non-frequently accessed data. And since here we can see that you can utilize the cloud environment for the sake of saving the storage and so on. So that is where your always encrypted feature can be very useful. You can encrypt your data. So if for some reason you do not trust Microsoft's Azure cloud environment, you can still trust them by using always encrypted feature and encrypt the data. So this way, not even Microsoft will be able to decrypt the data on their end and see what data you have stored in the cloud environment. So for that, we have the GUI-based tools, plus you can write the code as well and so on. Another new feature in SQL Server 2016 is called the temporal tables. Temporal tables, somewhat similar to this feature that's available in older versions like SQL Server 2008, 2012, 2014, is called change data capture or change tracking. So if you guys have used CDC or change tracking in the past, well and good. Temporal tables will be very easy to understand. If you haven't used it, it's basically about data versioning. So if you want to version your data, like what data got added recently. Let's say recently means after past midnight or past certain point in time, something that you have specified yourself, like you want to say from now on starts noticing what are the newly inserted records, what records have been deleted, what records have been modified. So you can basically keep track of the data that has been modified. And the historical data, you can, so basically the historical data is maintained as well. So when you modify the data, you have access to your modified, to the older version of the data. So CDC and change tracking, it has been available since 2008 SQL Server. But one of the issues with CDC or change tracking is that it can be a bit heavyweight. So it requires more resources, basically. So that is why in the past it was recommended to use CDC only for very short intervals. So store maybe a day's worth of data, not more than a day, because it does require extra resources, extra CPU, memory, storage, and so on. In 2016, we have an alternative to this change data capture, which is called temporal tables, and it allows us to version the data. You get to save the historical version or historical copy of the data, basically. And it's very, very lightweight. It doesn't occupy or consume too many resources, so it can be used over a longer interval, a longer duration, basically. You can choose to save days, weeks, months worth of data as well if you want. So mostly you'll want to use temporal tables for the sake of implementing data warehouses, or for ETL processes where you want to refresh your data warehouses and so on. So basically, if you want to keep track of what records have been inserted, modified, or deleted since the past, then for that you can utilize temporal tables if you want. It's all about data versioning basically. Whereas without temporal tables or without CDC, we often used to write triggers. So so we used to have, let's say, update trigger, delete trigger, insert trigger, and so on, and we used to manually copy over the records to some other table and so on. Whereas now we can utilize temporal tables. It has a built-in data versioning feature basically. It migrates the data or sort of creates a duplicate copy of it or the historical copy of the data. Then another feature in 2016 is Polybase. So Polybase is basically being able to utilize big data. So these days we get to use big data. So some of the companies, they have started using big data. So they have started using Apache Hadoop. So Hadoop you might have seen or used it in the past. If not, then basically it allows you to have a cluster of nodes that can process a huge amount of unstructured data. So it doesn't really have to be in relational table or tabular format. It can be a simple bunch of files as well. It can be any unstructured data basically. So when you have huge amount of data to process, then for that Hadoop is quite often utilized. And SQL Server has this Polybase feature which allows us to connect to Hadoop. It allows us to execute T-SQL queries that can connect to Hadoop, or it can connect to your SQL Azure blob storage as well, the external files basically, the unstructured files basically. So basically Polybase allows us to connect to or utilize big database features as well. And you have to enable it at instance level. And in order to make use of Polybase, you also get to use R language as well. So big data has its own language basically, which is called R. R is also available in SQL Server 2016. So basically it allows us to query your relational tables as well as non-relational unstructured data that we usually have in Hadoop, etc. and so on. And for that we get to use this stored procedure, which is available in SQL Server 2016, SP execute external script. So this is a bit out of the scope of this particular demo, since we have to set up lots of nodes and so on, but we do have some courses available on that as well. Okay, so here we have tried to cover some new features that are available in SQL Server 2016. So if you guys have questions, feel free to type them in the questions box. And as a consulting and training company, we offer various courses as well. So one of the courses that we have on SQL Server 2016 is mentioned on this slide, so 10986. Otherwise, feel free to contact us. We have quite a few additional courses as well. This course is mostly useful if you already have, let's say, SQL Server 2014, 2012, 2008 sort of background. Otherwise, if you are learning from scratch, then we have courses on that as well. Then I will definitely upload the slides. So you should receive an email. In the email, you should have the link. Otherwise, you can always go to the website, websolutions.com/webinars. Then just go to past webinar section and go to the My Club category, and there you should be able to see the webinars. You can also see the past webinars as well and so on. Thank you very much, guys. It was a pleasure to be here with you for the webinar. Thank you again.